Let's talk about ethics and statistics. If we're conducting surveys, is the survey question slanted in some way? For example, if we're surveying people about the construction of an oil pipeline, we could phrase the question in such a way that people think, yeah, it's a good idea. Do you approve the construction of an oil pipeline which would lower the cost of fuel? Makes people think they could save money. They like that idea. On the other hand, we could phrase the question in such a way so that people would be more likely to give us a no answer. Do you approve the construction of an oil pipeline which could contaminate the environment? Oh, and we need to make sure that we include a picture of the oil pipeline wending its way through the forest. People might think, oh, that's a terrible idea. So the way you phrase the question can lead people to give either a yes or no answer. And that's unethical. You don't want to slant your survey questions in that way. Did we cherry pick the data and use only the data that agree with our perspective? In 2011, author Eric Sigman submitted a paper about the effects of daycare on young children to the scientific journal The Biologist. Sigman's paper featured information from various sources and studies, but he only used information that supported his claim. Unfortunately, Daily Mail picked up on his paper and published the headline, "Sending babies and toddlers to daycare could do untold damage to the development of their brains and their future health." So again, by cherry-picking data, he gave a slanted perspective on the outcome. He misrepresented what the actual results say. That's unethical. Another example of cherry-picking is p-hacking. Recall that the p-value is the probability that we reject the null hypothesis if it is true. For example, suppose we are testing a drug and our level of significance is 0.05. If the drug is useless, there is only a 0.05 probability that we will reject the null hypothesis and conclude that the drug is helpful. With p-hacking, you test a drug many times and only report those times when the outcomes are favorable. For example, researcher Glenn Begley was trying to replicate a study of tumor growth in animals based off of a scientific paper written by an unnamed researcher. But for some reason, Begley could not seem to get the same outcome that the researchers did. So in 2011, Begley met with the unnamed researcher and described his dilemma to try and understand what he was doing wrong. The researcher explained that out of the 12 trials conducted in the experiment, only one was successful, and that was the trial that was published. No, you cannot do that. That's a wrong thing to do. That's unethical. Don't do that. Did we obtain approval from our research subjects? During the decade of 2000 to 2010, artificial blood was transfused into research subjects across the United States without their consent by Northfield Labs. Later studies showed the artificial blood caused a significant increase in the risk of heart attacks and death. The bad part here is that it was done without the people's consent. And notice, it wasn't in the distant past. It was just recently. Do we respect their privacy and confidentiality? Surveys sometimes ask questions about sensitive topics, illicit drug use, medical or financial information. You don't want the published paper to contain information that links individual people with individual responses. That would not respect their confidentiality. So be careful not to do that. Have we minimized the harm to our research subjects? The most notorious example of this is the Tuskegee syphilis study, in which researchers tracked the development of syphilis in 400 African American men over 40 years. These men just assumed that they were being treated for syphilis. They weren't. It's appalling. It's just terrible. Do we store and dispose of the data in a responsible way? Don't do this. Don't just dump the papers in a dumpster because, some people might go dumpster diving. And don't just press delete. That's not going to do it. There are ways that you can delete computer records that are more sophisticated than pressing the delete key. Do our big data algorithms reinforce inequities? There's an excellent book about this written a few years back by Cathy O'Neil, Weapons of Math Destruction, How Big Data Increases Inequality and Threatens Democracy. Loved reading the book. Here's some examples. Loan decisions are based on zip codes. So people who live in poor neighborhoods are less likely to get loans for no fault of their own, which keeps them poor. It's a vicious circle. Again, that's because banks are relying on these algorithms to tell them who's reliable and who's not. But you're just lumping everybody in the same neighborhood together, and that's not right. Sentences for criminals are based on their past criminal history. but people who live in neighborhoods with heavy policing are more likely to have a criminal record. Not because they're necessarily more criminal, it's just that there are so many more police around, so they're going to have more brushes with the law, and the police are going to catch them doing things. Again, this vicious circle. Teachers can be fired based on how their students do on standardized tests, but the sample size is so small that the test results may as well be random. If you've got 25 second graders in your class, maybe it's a good year, maybe it's a bad year, but you can't really hire or fire somebody on that basis. It's just too small a sample size. These inequities result when algorithms are opaque. They're black boxes. You put in the information and an answer is spit out, and it's not clear how that information led to the answer. Then there's no recourse, there's no redress, there's no appeal in that situation. And the other problem is that these algorithms lack self-correcting feedback loops. So for example, if a golfer tries a new golf swing, he can figure out whether or not that golf swing works. But if we're talking about an algorithm to determine who's a credit risk and who's not, there's no self-correction. If you reject someone for a loan, you're never going to go back 5 years later and say, gosh, should we have rejected that person for the loan? There's no self-correction. You're never going to figure out if you're excluding people that you should be including. So this is just one way that big data algorithms can really mess with people, and we need to be careful. There's value in algorithms, but we really need to be careful to avoid algorithms that are opaque and lack this self-correction.